Okay, so here we are at lesson 2, one of the most important parts of the paper I'm going to fill out for you. So finding solutions is actually like the basis of all of the quadratics, but you're going to learn how to find a solution in all 3 forms, and by a graph, by an equation, or maybe even by a table. So, I mean, it's a way to put everything together. Wow, I'm outside and everything is flying away. Very cool. And also, like the quadratic formula, for example. You've heard of it, and it's just a way to find the solutions. So, how we solve for x. I guess first to I don't know if I wrote this down for you before, but for example, if I tried to find you the solutions, let's say you're trying to solve for x. Let's say this is equal to 5. So again, let's just imagine you're solving for x. I would want you to pause the video here and solve, see what you can do. I'm gonna just do what I think you might do. This is like the best lesson, I think, that I like to open my lessons like this because I think it makes it a little bit more understandable. If I'm trying to isolate x, I might know that I subtract 2 on both sides. You've done this. Oh, little spider friend. Cool. Really not a fan. Yikes. So now, okay, maybe I subtract 3x. Okay, I'm not, nope. X squared minus 3x minus 3x. Move things over, 3 minus 3x. And then what? Wait, how do I isolate x? If I have an x squared here, don't get distracted by that spider. What, should I square root both sides? But then I have, wait, and then you erase that and you're like, oh, do I x squared equals 3 minus 3x? Well, before I used to like divide by 3, so maybe I like divide everything by 3, and then you're like, this doesn't work. Like, I don't know about you, but you are not going to get something that ever gets you x isolated. You'll get something where x is close to isolated, like in this case, but you still have an x squared. So the answer is, you can't do it. You can't solve for x when there's an x squared and an x. Whoa, Math 2 students, that is the whole point of this, is learning how to solve for x when there's not just one x. And this is really not working well outside, so I might move inside. Lots of wind happening. So anyway, we're trying to solve for x. We are trying to find the x-intercepts because you guys know solutions equals roots equals, in many cases, the x-intercept. So we're thinking of this, instead of thinking of this as a thing we can solve with algebra, we're going to consider this as a parabola on a coordinate plane, and we're going to find the x-intercepts. That's going to be a little bit easier for us. So if you'd like to do this warm-up, you can. 5 times 5 is 25. If you wanted to do 5 squared equals 25, what they're getting at here is that you square root both sides to get 5 by itself. Voila. That's the inverse of a squared is a square root. Okay, so here we are on page 707. Whoa, okay, fun. A classic. And we're going to ask for ourselves that, let's say a quadratic x squared equals 9 is as simple as we can get. Can you guys isolate x here? Because the answer is, in this case, it's simple enough that you can. To get x by itself, we do the inverse operation. To get rid of x squared, we square root both sides. And now this is the most important part you need to see. X is now going to be 2 different options. We have the positive case and the negative case. So the answer could be 3. I'm interpreting this, I'm translating this into English. 3 or negative 3 would both work. So let's say, okay, fine. We got 3 options, either x equals 3 or x equals negative 3. We've got this thing called a plus or minus, which is going to be the bane of your existence. It was the bane of mine when I was in high school. You're used to your teacher like wagging their finger and saying, don't forget the plus or minus, and it's obnoxious. But the reason is that if you plug it back into the original equation, x squared equals 9, 3 squared equals 9, but what's negative 3 squared? Also 9. So there are two answers, the positive case and the negative case. And that is why sometimes we have two different solutions. So over here, they've decided to show you how to do it algebraically by square rooting both sides, but they also want you to graph it, because an easy way to do it if you can't do it algebraically is to put it on a graph. So if we said that x squared has to equal 9, we are asking for what input of x would get us an output or a y value of 9. So where's our y value equal to 9 is what this is asking. What do I have to put in to get 9? We already know the answer is 3 or negative 3. But let's take a look at this graph. We're asking, where is this parabola going to have a coordinate point where the y value is 9? So they graphed it for us in blue. This is the height of 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is up here. And the graph is up at 9 here and here. And so when we ask which x values does this work for, the answer is, down here at negative 3 and over here at positive 3. And if you did the Mathia section on absolute value, this is also a strategy you use for absolute value. You can do it for any graph, which is if the y value equals this, let me look and see what the x value has to be. Oh shoot, it's 3 and it's negative 3. Now, this is maybe confusing. I'm going to say if you're confused, if you're not sure what is going on here, that's okay, because our best strategy is actually to shift, don't freak out, shift this parabola down so that these two things are the x-intercepts and are the solutions. So from now on, we're going to change our quadratics so that their x-intercepts are always the solutions. If you'd like to finish up this page, you may, but I'm going to move on. Over here, we have a definition of a double root, which is what happens when there's only one x-intercept. But I'm going to show you what this looks like here. So consider the... Hi, also. Hi, it's my shadow. Here are three functions, and it says, consider them, and then identify the solutions. So, what are the solutions of a graph? They are the x-intercepts. So you are going to identify the x-intercepts of each of these. I would like you to do this in your book right now on your own. Pause. Here, 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 and then nowhere. So this one, x equals 0. This one, you might have to estimate. Let's say x equals, it looks like negative 2, almost 3, negative 2.9, and maybe 2.9. I didn't do a good job writing this in pencil. And then you'll see here there are no solutions. So if we're looking at this graph, you guys can see it very nicely with your eyeballs. But when we see these equations, there's actually a way to solve algebraically. So I'm going to say this here is solving graphically. You don't need to write this in your book, but you just practiced solving graphically by using your eyeballs. Just freaking look at it. That's a way to solve. Now we're going to do it algebraically. So algebraically means, let me focus here, means that we want to see the x-intercepts, and the x-intercepts are where y equals 0. So I put this in your notes weeks ago when we first did parabolas. But if x-intercepts are where y equals 0, that is our key to solving this. So I'm going to say if y equals x squared, let's say 0 equals x squared. And now let's solve. How to get x by itself? Well, you square root, you get plus or minus the square root of 0, but we know positive 0 is the same as negative 0, and now x is isolated, and that's our answer. down here, let's do this algebraically. I'm going to set x squared minus 8, which is this equation. I'm going to pretend like I can't see the graph. I'm going to do this algebraically by setting this equal to 0. So, okay, let me try to solve for x. Well, I can add 8 to both sides, add 8 to both sides. X squared equals 8. And then I square root both sides, and I get x equals either the positive square root of 8 or the negative square root of 8. I wish you could ask questions right now, because I know some of you are thinking that you have questions. And you say, Miss Robert, I don't know that number. And the answer is, me neither. It's something very, very close to 3. And if you plug it into a calculator, it's going to be a number very, very close to 3. So as we estimated here, graphically in this case might let us down a little bit. So looking at the graph is like estimate, I don't know. But if we do it algebraically, we have the exact decimal that will work. So I don't have a calculator on me, but if you plug this into your calculator, these, the plus and the minus of 2 point something, 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 are the actual numbers for sure of the x-intercepts. Last one, of course, this is really fun. Oh, this is so fun. I'm sorry, I'm just so excited. Let's say you set this one equal to 0. If we subtract 2 on both sides, and then we, I don't know, square root it. Hey, smart brains, what number squared is going to get me -2? I'm pausing for dramatic effect and for your brain. Let's see. Well, 2 squared is 4. 1 squared is 1. -1 squared, well, -1 times -1 is +1. Everything I square is a positive number. I'm never going to get a negative number out. So when you square root both sides and you have a square root of a negative, that is impossible. And your calculator will tell you that by saying there's an error. You will never find a solution. You will never find an x value that you could plug into this that would ever give you a negative number. So these are when there are no solutions, because they do not exist, and we call them imaginary. Because negative square roots are imaginary, and I think that's in your book later. So, good work on this. I would like you guys, of course, to practice doing this, square rooting both sides. You can use it, let's see, determine the solutions algebraically on these 3. And then, which function has a 000? Okay, that's fine. This one has a 000 because it goes down. That's back up. But yeah, just do these. Just literally just square root them. Voila, square rooting. Once you isolate the square root, I'm going to get this by itself. So I get 12 equals x squared. You just square root both sides, and your answer is x equals whatever the heck the square root of 12 is. I'm not sure. 3.5-ish or something. So try this on your own right now. Please don't forget that there are 2 answers. So the answer will be plus or minus the square root of 12, whatever that decimal is, because this parabola is going to have a plus version of the intercept and a minus version of the intercept. Enjoy, have fun.